Welcome back, friends of the internet, where we are going to go through one-point perspective today. My notes on one-point perspective, based on free resources online, which you can find links to in the description below, and all of this information is available for free. I'm just going to provide more of a walkthrough of what I've discovered through my process of learning this stuff. So this series is going to be a let's learn together type of thing, and I hope to practice together all of this stuff. So this information is mainly based on a quote-unquote class, online class given on a website called Crimson Daggers, which is a free website forum where there's a little community and they have really top quality information out there, and it's really difficult to find. So Crimson Daggers, so you don't have to take any notes or anything like that. All of the information that I'm going to give, I'm going to put links to the resources and detailed description in the description of the video, to the places where I took this information from. So without any further ado, let's move on to the screen and let's move on to my notes. So here on the left side I have, hopefully you understand what's written, because I use the software program, which I have the link to in the description, to take notes on my tablet, and anyway, to make this PDF. And over here I have on the right side MyPaint to exemplify some of the things that we are going to go through, and hopefully we're going to zoom through all of this very quickly. Alright, to begin with, we have some technical terms to go through. Horizon. It's not the natural horizon of the Earth necessarily, because say for example you're a bird or you're in space. But in space you do have the horizon of the system, and all of the parallel lines that recede in space, they converge to the vanishing point, which is the second term over here. The vanishing point is the point at which all of the receding lines, parallel lines, go to converge. And then we have this diagonal vanishing point over here, and I should have made some notes over here, but basically this will come in handy later when I go through an example of creating some funky stuff. Not funky, it's a bit more advanced than the usual thing that you find online. I exemplified in this type of educational videos on perspective. So we have not necessarily a square, but over here I quote-unquote made the square on the ground, and if you continue the diagonal line and intersect it with the horizon line, then that's called the diagonal vanishing point of our square in this case. And this is dependent on the viewer's proximity to the vanishing point. So over here, even though this might look closer to the vanishing point, it's actually farther away in terms of painting the perspective. And yeah, as you can see, like if this would be a square, the further you go away from the vanishing point, the more distortion you would have, so watch out for those. Second thing, finding the middle in perspective. If you have two objects, they have the same height but they are placed in different depths, then to find the middle of that, it's really easy. You just say for example you have an object over here and you have a second object over here, and they have exactly the same height. So I messed that up, and I should have created this first and this first, and then this is the placement of the second object in depth. So to find the middle of this, you just draw the diagonals of that rectangle, and then you just connect the lines, draw a vertical line in this case, and you can use the same method for things on the ground as well. So you just create the diagonals like so, and then you just make a horizontal line going through the middle point of the diagonal, the intersection point of the diagonal. So that's finding middle. Second thing, transferring height in perspective, in one-point perspective. So to transfer the height, say this is the vanishing point, horizon, and we have an object over here, and we want to place it somewhere over here, which is at some other depth. You just create a intersection, the horizontal line going from the base of the object to the vanishing line of this object, and then find the height, transfer the height like so, and then you have the object, just like that. Simple. And to do the same stuff but for an object that isn't on the ground plane, you just have to calculate the intersection with the ground. So basically you extend this like so. The height, the verticals are going to be exactly the same no matter where they are in the same plane that faces us. So what that means is that I just need to copy this, which I don't know how to do in MyPaint, but I just need to copy this object, put it on the ground, and then use the same technique to let's say we transfer it in exactly the same place. So like that. Hopefully it's understandable. Let's give them maybe different colors. So this is actually, this is object here and this is the same object here, and let's try this green. All right, next thing. So this is called transferring scale. Hopefully that's written correctly. Okay, cutting through shapes, and over here I have a more complex shape. It's like a prism of some sort. The main idea is just to draw through everything, and don't the lines in the background going through your main drawing and whatever, because they can be cleaned up later. So to find the middle of the height area, just create the diagonals, find the intersection point and draw the horizontals, and find this intersection to the sides, and then just extend this to the height that you want. I want to go through this fast, and then just connect these dots so you have the sloping parts of this rectangular prism thing. And now we want to cut something through it, so just pick the width or the length that you want to cut through and connect it to the vanishing point. Find the intersection to the middle line, extend those up, because this would be like the top parts. This would be connecting these points, is going to define the slopes on the face. And then just pick, you know, like whatever I want to cut this part. And that's it. And continue this line to the vanishing point so that I find the horizontal plane like this. And there we have it. That's our shape cut. Moving on. Multiplying and dividing rectangles. This is very useful and not so difficult actually. So over here I have on the ground, but I'm going to mix up and use side planes. So on the ground, say for example we have this object and we want to multiply it, then it's very simple. You just create diagonals, find the intersection point of the diagonals, draw from vanishing point through the intersection point. So you find this intersection here with the side, and then just draw other diagonals going through those points, and then this is going to define equal lengths in depth. 1, 2, 3, 4. Here is multiply in depth. Next up is divide in depth. So same situation, we have the plane, but instead we have this dimension we already know, and we just need to divide it, and it's the same idea. Just draw the diagonals like so, and then you can draw through the intersection point of the diagonals, and then you can continue the process. Come on, be more precise, and you can continue the process like that and like that, and that's pretty much what you need to do. It's simple, really simple. So 1, 2, 3, 4. Now over here you can multiply as many times as you want, so it's even and odd. You can multiply even and odd numbers, but over here this method only gives you even equal divisions. So what do you do if you, say for example, want to divide in 3 or 5 or odd numbers? Well, let's take a look at that. We have the same situation, but instead of relying on the diagonals that way, we are going in the third method over here, and basically we are going to divide with a measuring stick or an assistant or something like that, or just eyeballing this horizontal part into equal parts, something like that, and like really precise over here, as you can see. And this is where we need the diagonal vanishing point. This is vanishing point and this is the diagonal, and then you just extend these divisions to the diagonal vanishing point, and then find the intersections over here and draw the horizontal lines, and that's it. And these are equal. 1, 2, 3. So odd. Actually this is even and odd divisions. Okay, the third bonus method of using this diagonal vanishing point idea It's actually really cool, and let me show you quickly over here what I mean by that. Let's start off by using a vertical plane in this case, and let's say, for example, we are given a plan of the building, and we see from above something like this. This is what this is over here, badly drawn. But anyway, and say, for example, we are given the information that 1/4 or 1/5 or whatever this is of the side of the, let's call this bottom and this front, we are given this division on the bottom part, and we want to find it. How can we do that? Well, it's relatively easy. We just need to find the diagonal vanishing point, which is in this case is connected to the vertical line going through the vanishing point. So this is TVP. We use this vertical line over here just as before as a measuring stick, and then 1/4, let's say, is around here, and then we just need to connect the points like so, and there you have it. We found this 1/4 of the side part, or the receding part of our plane, and yeah, let's create a vertical there, and that's it. Moving on, this is more of an advanced topic where it's also a bit technical, the case of a sloping plane and stairs more specifically. So let's quickly go through the example, because it's not in fact that complicated, it's just that you have to keep in mind something. So we start off by defining our height and depth of what's it called, the step of the stair. So this is the height and this is the depth, and we need to find the intersection of this to a vertical line going through the vanishing point, and this is going to be the vanishing point of the slope. And once we have that information, we can easily create our stair just like this. So the vanishing point of the slope is going to provide us the information for the sloping planes. The sloping planes, they are all parallel, and the sloping planes are one for the bottom points of the stairs, bottom of the steps, and the plane defined by all of the points of the top part of the step. So over here we have top, and over here we have bottom, and we connect. So the slope vanishing point, this would be the bottom plane. Pick a height, this would be this h, and then just connect the points just like that, and that's it. We have the planes, and now we just need to find the horizontals to this, find the intersections, and just it's mindless from here on out. Just connect points, that's it. As you can see, it's so easy, anyone can do it, except I made a mistake there because this was supposed to go here to the top. Just to make it more readable, I'm going to outline it with a thicker width, and that's all there is to it. Over here in my example I have a bit more complicated stuff, because I also included the railings or whatever you call those things, but it's exactly the same idea. Over here we have the horizontals, the planes, horizontal planes, and over here we have parallel planes that go to the same vanishing point of the slope, because these are parallel to the tops and bottom planes of the steps as well. Finally, I'm going to go through some tips and tricks or something like that. Good practices, let's just call them, in general, not necessarily for one-point perspective. So the first one is place references. So let me give you an example. If I were to make a quick figure over here, quick badly drawn figure over here of a human, you can see how the steps immediately look like they're for giants. But if we make something like, you know, like a normal, regular human height, it's not even that regular, then we can see how the stairs immediately look like something else for us. More like, still for giants, but closer to reality. So place especially figure to establish scale in your drawings. Check for tangents. So over here we have the situation in which these two boxes, they are one is in front of the other, one is closer than the other. The big one is closer to us than the smaller one, but because the smaller box has the side plane coinciding with the vertical line of this one over here in the left side, it ruins the illusion of depth. So In order to fix that, we just need to fix our boxes so that they're not aligned in such a way. Third, don't be afraid of overlapping shapes, and we see a lot of examples over here of why they are good for us, because if you draw through and you don't care about overlaps in this sense, then you can be very precise with your lines. And the best example is over here with cutting through this rectangular prism thing. So in order to create this particular drawing, I had to make all of the connecting lines, otherwise I wouldn't know exactly where to cut. Let's see, use the thickness of lines so that you can establish better readability of your drawings. So don't use the same thickness overall. This is connected to something called atmospheric perspective as well. So when something goes into the distance, then it becomes smaller. So if think of the line going in the distance towards the vanishing point, then it also has to shrink, like logically. So over here in the example in the left, I have the same thickness for the lines, and it kind of ruins the depth illusion, whereas over here I thickened the outline of the boxes and kept the inside lines thinner, and I also thickened the box that is closer to us. I made it the outline thicker than the box that is further. You can also use this technique to play with sun and light idea, so everything in the shadow part, thicken it, and this would give the illusion of shadow. At least, you know, if you don't have cast shadows. And this isn't necessarily to say that you should use this only for outlines. Like we have the example over here where I have drawn like a cutout inside of this box, and because the sun is on the other side, in the left side coming from the top, then the top planes of this cutaway piece is actually in the shadow, so I thickened that part. And finally, this is something that beginners do also, avoid this situation where you have one side going through exactly the vertical place of the vanishing point, the vertical line going through the vanishing point. So instead move your box left or right to make a better drawing. And that's it for the notes part. Hopefully it's been short enough and it's been quick enough and it's been informative enough so that you take something out of it. Thanks for dropping by my YouTube channel. If you find anything interesting over here, help me out with a subscription, a like, a share on the social media so that we can spread the word to the ends of the universe about free online resource on how to draw and paint and my process to learn it. I mean, I'm not a teacher, so don't take anything that I've said over here as absolute truth. Go and do your own study, your own research, and I'm going to leave you with the links on the description under the video. And go have your read and do your assignments, do your homework. So in the next part of the video, we're going to do the assignments that Israel Carrion is assigning in his quote-unquote class online. And hopefully we're gonna have a nice time together doing that. See you next time.